Okay, so we're back with number 3, and the percent of US population with internet service can be described by that equation, where X is the number of years past 1995. We are asked to identify and interpret the slope and the y-intercept of this equation. So let's remember that the slope is always the number that is attached to the variable. And so in our case, the slope is 6.9, meaning that every year the percent of people in the US, or households in the US, increases meaning that every year the percent of households in the US with internet access increases by 6.9%. Okay? We are also asked to interpret the y-intercept. So the y-intercept is negative 3.18, meaning that in the beginning, which would have been 1995 in this case, in 1995, negative 3.18% of households had internet access. And it's important to understand that this doesn't make sense. And this doesn't mean that our equation is flawed. This means simply that the equation is only valid for years past 1995. So not including 1995. Okay, so let's move on with our lives, folks. Let's look at section B. And so I actually wrote this one. This one's kind of a tricky one. What percent of the population does this model predict will have internet access in their homes in the year 2020? And so what we would end up doing for this, everyone, is we would put 2020 is the time, and that's going to be X. And so that's since 1995. So 2020 is 25 years after 1995. So what we've got to do is take this model. And again, 2020 is 25 years later. So we would say 25 goes in for X. And we'll let Wolfram do some magic for us on that. We're going to see what we get. So here we've got y equals 6.9 times 25 minus 3.18. And so this is giving us 169.32. So y equals 169.32. This would mean, let's interpret this result, everyone, in 2020. 169.32% of households will have internet access. And of course, this does not make sense because it's impossible for more than 100% of households to have internet access because 100% is everyone. So one thing that's important to understand about these models and things, folks, is that they often only are valid for short-term use. And so in this case, 25 years in the future is too far ahead for this model to be useful for predicting something. And so again, this is an invalid having trouble writing today, everyone. This is an invalid result. We need a new model. Okay, that's going to be it for number 3. I hope this was helpful. We'll be back with the next one.